In order to add and subtract integers, what we are going to do first is remind ourselves what integers are, and that is that they are whole numbers and their opposites. So here are some examples: 1, 5, -2, 7, and -11. And of course, the opposites of all these numbers would be integers as well: -1, -5, 2, -7, and 11. So I've been teaching math for quite a few years now, and I've seen a lot of different models for how to add and subtract integers, and I'm going to show you a few of them before I get down to a way that I think works for most students, but I always want you to choose the model that works best for you. So this first model uses algebra tiles. I like using these because we will see these when we begin to start solving equations and inequalities. And what these tiles are, the little yellow tiles have plus signs on them and they stand for positive. This is a +1 and this is a +1. And the little red tiles have a little negative symbol on them. They stand for a -1. So this is a total of -5. So in this example, 2 plus -5, I've got 2 positives and 5 negatives. And what happens when I've got a +2 and a -2 is that they cancel each other out. They become 0. This is called a zero pair. If I have 2 of something and I take away that same 2, I end up with 0. So since these cancel each other out, I am left with a total of 3 negatives, or an answer of -3. In this second question, I've got -3 subtract 4. Well, that's 3 negatives and then 4 more negatives, which gives me a total of -7. Nothing in this one pairs up to cancel out because there are no positives here. So this is a total of -7. Now we can do those same problems also on a number line. 2 plus -5 and -3 subtract 4. Well, I start with the first number, so the first number is 2. And this says plus -5. This is the negative direction on a number line, and this is the positive direction on a number line. So when this says add -5, I need to move 5 towards the negative side, which is this way. 1, 2, 3, 4, 5, and I've landed at -3. So this is the same problem that we already did, but instead of using the algebra tiles as a model, we're using a number line as a model. Second problem, I begin at -3, which is right here. And it says subtract 4, which means I'm going to move 4 in the negative direction. 1, 2, 3, 4. And I've landed at -7, so the same answer that I got before. I don't particularly like the number line model because it kind of takes a lot of time to draw this for every problem. And if I had big numbers, for example, if I had 71 plus -125, I don't want to have to find 71 on the number line and then count 125 in one direction. So the number line model doesn't work best when we start getting larger numbers and more complicated problems. So before we continue, I want to talk about absolute value, which we've talked about a little bit before. I just want to remind us that absolute value is a number's distance from 0. And because it's distance, we learn that absolute value is always positive. Now that doesn't mean the answer to a problem is always going to be positive. It simply means what comes out of these up and down absolute value lines will be positive. So the absolute value of 8 is 8. The absolute value of -3 is 3. These are distances. If I found a number line and put the number 0 on it, 1, 2, 3, 4, 5, 6, 7, 8, and the number 8, there would be 8, 1, 2, 3, 4, 5, 6, 7, 8 spaces in between those two numbers. And in the same way, if I made a number line with the numbers 0 and -1, -2, -3, there would be 1, 2, 3 spaces there. So what comes out will be positive. Let's look at these examples down here. The absolute value of 17 is 17. What comes out will be positive because it's a distance. The absolute value of -17 is 17. This would be 17 spaces away from 0. And now here's the tricky part. Remember I said what comes out will be positive, but that doesn't mean the answer to a question will be positive. The absolute value of -17 is 17. I just did that problem right here. But then this negative sign that was on the outside will come down and join the answer, giving me a -17 for my final answer. So here are the rules that we're going to use. And remember, the best part about these videos is that you can pause them to copy down information at any time. So the first thing we're going to do is we're going to look to see if the numbers have the same signs or if they have different signs. And then there will be 2 steps. If they have the same signs, we will add the numbers together and keep the sign. If they're both positive, my answer will be positive. If they're both negative, my answer will be negative. If the numbers have different signs, we are going to subtract them. Here's an easy way to remember this. The word difference is another word for subtraction. So if they have different signs, we're going to find the difference. We're going to find the difference between the 2 numbers. And then we're going to keep the sign from the bigger number. And I put that in quotes, and you'll see that in just a minute. Now, we need to remember that the sign in front of the number belongs to that number. This is a -3. This is a +7. This is a 7, and since there is no sign in front of it, I know that it's positive. This is a -15. This negative sign belongs to it. This is a -8. This is a -11 and a -20. So remember that the sign immediately in front of the number belongs to it. So let's go ahead and look at some of these problems. -3 plus 7. These are different signs, so we're going to subtract. 7 take away 3 is 4. Now I need to decide if this answer will be positive or negative, and we need to keep the sign from the bigger number. I've said bigger in quotes because at this point I'm going to ignore the signs in front of them. What's bigger, a 7 or a 3? A 7 is bigger, and because this 7 was positive, my answer will be positive. And a good way to think of this is to think of those tiles that we saw in the very beginning. Here's what it would look like. I would have 3 red tiles, and I would have 4, I'm going to use black instead of yellow, but I would have 7, 1, 2, 3, 4, 5, 6, 7 of the positive tiles. And what would happen would be that these 3 would pair up with these 3 and they would cancel out. So what's left? Those 4 positives. So that's the idea behind keeping the sign of the larger number. Because there would be more of that color tiles, that's what the answer will be. That would be what would be left. So here I have a -2 and a -13. These have the same signs, they're both negative. Same signs, so we add. 2 plus 13 is 15. And I keep the sign. They were both negative, so my answer is negative. This is like saying you owe me $2 and then you owe me 13 more. In total, you owe me $15. Let's jump down to this problem right here. I've got a +7 with a -15. Those are different signs, so we subtract. 15 take away 7 is 8. And I need to keep the sign from the bigger number. I'm just looking at the numbers, not the signs right now. I've got a 15 and a 7. Which is larger? The 15. And the 15 is negative, which means my answer will be negative. You could think about those algebra tiles again. If we had those tiles from our very first model, it would look like this. We'd have 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of those negative tiles. And we'd have 7 positives. 1, 2, 3, 4, 5, 6, 7. So all of these would pair up and cross out, and we'd be left with a bunch of the reds, which are the negative pieces. I'd like you to finish the other questions on this page, and you'll notice that this question has a star next to it, and that's what we're going to talk about on the next page. So here's that last problem from the last page, and it was 5 take away -3. Now, this is called a double negative, and that happens in English as well. A double negative is when you use 2 words that mean something negative, like don't. So if I said, don't not wash your hands, what I'm asking you to do is to wash your hands. Oops. It's weird because the 2 negative words, don't and not, turn into a positive command. I want you to wash your hands. So if I just said, don't wash your hands, then I don't want you to wash your hands. But with that not that goes in there, these 2 things become a positive, and what I'm actually asking you to do is wash your hands. Now, I'm sure Miss Simon can give you a much better definition of what a double negative is, but the idea is that when you have 2 negatives right next to each other, they become a positive. So last year I had a student show me that this is what she likes to do. When she sees this double negative, 2 negative signs right next to each other, she joins the 2 negative sides and uses the parentheses, and it becomes a giant plus. So this problem is actually 5 plus 3, which is 8. I'm going to use that same trick. I'm going to turn this into a giant plus sign. 20 plus 4 is 24. Same thing here. These become a giant plus sign. Now notice this negative out here was not part of it. It's just the double negatives right next to each other. So this problem is now -8 plus 9. These have different signs, so I subtract. 9 take away 8 is 1. And I have to decide if it was a positive 1 or a negative 1. What's larger, an 8 or a 9? A 9, and this 9 is positive, so my answer is positive 1. You'll also be asked to evaluate expressions. Remember, when we are asked to evaluate, every time you see a variable, you're going to leave space using a bubble. Bubble is just an open set of parentheses. Now I have room to go back and fill in. Whenever I see an x, I'm filling in -5. Whenever I see a y, I'm filling in 3. And whenever I see a z, I'm filling in -8. And right here is the perfect example of why we use bubbles, so that we don't lose track of any of these negatives. I'd like you to solve these problems keeping in mind what happens when you see 2 negatives right next to each other. Keeping in mind what happens when you see they have the same signs. And remember that what comes out of these absolute value symbols will be positive. At this website, tinyurl.com/carnes-add-integers, there is an awesome pirate walking the plank game that will allow you to practice adding and subtracting integers. Have fun!